Hey everyone, welcome back to the DBMS series. This is episode 2 and today we are going to learn about two very important and basic concepts of databases, data abstraction and data independence. If you have not watched episode number 1 yet, where we have explained what is DBMS and why it is important, make sure to check that our first one. Let's dive in data abstraction and data independence. So, what is data abstraction? It is simply means hiding the complex data details of how data is stored and showing only the important information to the user. Think about it this way. When you use Google Map, you just search for a location. You don't care how the app fetches data, uses GPS, or calculates routes. You just see the map and the result. That's abstraction. DBMS also works in the same way. There are three levels of data abstraction in DBMS: view level, logical level, and physical level. Physical level, this is the lowest level where actual storage details are handled. We focus more on how data is stored in memory, blocks, or file. The second type, logical level. This shows what data is stored and the relationship between them. For example, suppose we have a table, student, course, and marks, then we'll see that how they are connected. That's the job of logical level. The third level is view level that normally hides the details of data types as well as other implementation detail. Example, a student only sees their marks on portal. Each level hides the complexity of the level below it. Now, let's look at the second point, that is data independence. So data independence, this is one of the biggest advantage of using DBMS. It means that the changes in one level of the database should not affect the other level. That way, the system becomes more flexible and easier to maintain. There are two types of data independence: logical data independence and physical data independence. So let us focus on logical data independence. Changes in logical schema, that is, if we add a new column or remove existing column from the table, it will not affect the external views or a user programs, means it will not affect the upper level, that is view level. That's called logical data independence. For example, you add an email column to the student table, but the app used by faculty still works the same way. That's called logical data independence. Next is physical data independence. Changes in how data is stored physically, like using a new file system or a compression, should not affect the logical structure. For example, changing storage from hard disk to SSD doesn't affect how your tables are written. Make the system strong and easy to upgrade. Let us take a simple example to understand both the concept. Imagine an ATM machine. When you use an ATM, you only see the screen and button. This is like a view level. The bank that manages your balances and transaction is logical level. And finally, the server and the database that store all this data physically, that's the physical level. Now, if bank changes the storage system in the backend, your ATM experience stays the same. That's data independence. Let's quickly recap what we learned today. Data abstraction hides complexity from the user. It has three levels: view level, logical level, and physical level. Data independence allows changes in one level without affecting the topmost level. There are two types of data independence: logical data independence and physical data independence. Thanks for watching episode 2 of our DBMS series. If you like the video, hit like, share it with your classmates, and don't forget to subscribe. In the next video, that is episode number 3, we shall explore system architecture of database management system, a very important and foundation topic. See you in the next video. Happy learning.